My name is Chris Molater. I'm a network engineer for TDS. We have a lot of brand names we go by, so some of them are probably more familiar to others of you in different places. I jumped on the opportunity to moderate the IX panel, and I'm not going to talk very long, but I jumped on it because I thought it would be awesome if a SP moderated the IXs for a while. Basically, the format for this is going to be quite simple. Introduction, speakers are going to speak. They're going to have 5 to 7 minutes each. I'm going to time them. I will cut them off. At the end, there will be time for you to ask some questions. I'll do a quick closing, and then we'll get to beer, because I realize I am all that's standing between you and the remaining beer in Las Vegas, so I'm going to go fast. Order is pretty simple. I'll introduce them one at a time as we go through it, and I'll try not to butcher everybody's pronunciation, but I might very well do that as people butcher mine, so I think I get to butcher back. So with that, Josh Snowhorn from NAP of the Americas.
Thank you, Mr. Maliater.
You want me to do fonts for you?
No, yeah, sure.
Okay.
Stay here. So I just want to point out the NAP of the Americas. Everybody's always said that we're a great data center, wonderful. We actually now have big balls. We actually get to show that now on top of our building. And we actually have we have a new flux capacitor peering switch. You can actually see that on the projector over there. We're trying to be innovative and look for a new switch inside our facility, and self-powered, little time travel things, do some cool things with your packets. But yeah, blinky lights, exactly. We actually ended up getting rid of our foundries and bonfiring them, actually, and putting in some new Force 10s. We're the first big exchange, I think, to do this. We like them. Great switches. Have really high density, 10 gig availability. And in the future, as we go into the terascale blades, we can actually get 672 gigs of ports per box, which is pretty cool. Very heavy box, but still pretty cool for what we want to do. Basically, what we're looking for. Oh, yeah, different slides than I have now.
I had to split it for size.
So feature requests we're looking for: lighter chassis, additional layer 2 features, mainly MPLS stuff, basic CLI stuff, enhancement, show interface, a little bit better S-Flow, which they're working on, and more blinky lights, bigger logo, all that kind of good stuff. The things do show pretty well. So this is our configuration that we're running inside NAP of the Americas. We're running these also in our Madrid facility and our Sao Paulo, Brazil facility. And basically 40 gig trunking between 2 switches. And we do have 10 gig available right now. So it could be pretty interesting if there's any uptake on that. Also in our Meet Me room, we're doing some pretty cool things. We bought these big Lucent Lambda Unites, which allow us to do this basically a giant mega mux inside the facility. It's OEO right now, 320 gig backplane. Right now we actually have 3 of them in place, 2 of them are full. It's a pretty interesting way to show a stat of what you can do in exchange via the Meet Me room instead of just straight Ethernet stuff. But definitely pretty cool. So what we're looking for: requirements, full redundancy, 100% hitless code upgrades, 100% survivability on brain death, more granular management features on our feature requests, DCC transparency, more Ethernet layer 2 support, and a lot of that stuff's coming in pretty quickly. Lucent's been pretty good to us. And it's got no blinky lights, but it's pretty cool when you got a few hundred fibers going into these things. So basically what we're doing, because the NAP of the Americas is so big, we have multi-floors, 750,000 square foot facility, a lot of distance issues and things like that, but this cures it all. We're able to do copper interfaces, fiber, everything else over longer distances, and do a lot of really neat grooming. Somebody delivers an OC192, we can peel out private peering for them at OC12, they can do customer delivery on another OC12, whatever they want to do. So it's pretty neat features for us. And that's it. I kept it under 2 minutes, I think.
We put Josh first because he's the fastest. Next I have Yuki Asu Tarui from JPNet.
Hello guys. My name is Yuki Asari from Internet Smart Speed. We are operating Ethernet-based layer 2 IX in Japan. So, it's an honor for me to make a presentation in here, NANOG meeting. And today, I want to speak 3 chapters and milestone and problems in last year and to-do list for next. First of all, I'd like to speak to a 10GE experience on JPNAP. We served, JPNAP served 10G error interface for customers since 2003. So we already have 2-year experience about 10G operation. Currently, number of 10G users is over 20. From our experience, interoperabilities between 10G equipment are also no problem. And recently, there are 2 trends. First one is dozen ISPs migrate from multiple gigabit Ether link to 1 gigabit Ether link. It can handle huge traffic more easily for ISPs. Second one is some major ISPs already start to use multiple 10G ports. So we need to prepare more wide bandwidth interfaces. And so to handle such huge traffic, we've installed a new switch platform last year. It has 40 gigabits backplane per slot, and it can bundle 8 10G ports in maximum. Currently, JPNAP bundled 4 10G ports without LHCP. Load balancing on those aggregated link is pretty good. And our SDP, rapid spine 3 runs in JPNAP core cloud. It can be able to reduce an impact on customers' traffic exchange during layer 2 topology change. So another approach is toward a more stable network is intelligent optical switches. Oh. The purpose for installing this optical switch is to enhance the redundancy for customers. In this diagram, yellow one is this yellow one is our optical switch, shows our optical switch. And there are 3 ports for connecting the equipment. 2 of them are assigned for JPNAP switch, and it means main and backup link, and the other is for ISP routers. This optical switch can monitor receiving optical power from JPNAP switches, and once primary link signals will stop, optical switch can detect that failure and switch into backup system automatically. It takes less than 10 milliseconds, so almost all kinds of routers do not alert link down, and Ethernet switches run a topology change very well because ISP routers continue to flow the packet, so JPNAP switch can refresh the MAC address in short time. As a result, BGP pairs between ISPs do not reset. That's why we can reduce an impact on ISPs, customers' traffic exchange during JPNAP switch travel or scheduled maintenance. And this graph shows JPNAP total aggregate traffic. In last 2 years, there are 3 phases of traffic trend. First is growing period. First, in this period. First is growing rapidly. It went doubled every 6 months. And next, traffic stayed nearly flat on first half of 2004. However, recently, last 6 months, it began to grow again. So one of our big problem 2004 was that traffic trend was not predictable. To achieve such huge traffic exchange stably, we have planned 3 action items in 2005. First is analyzing and visualizing the S-flow data. It's hard for us to handle such huge traffic without detailed statistics. I expect S-flow data is useful for JPNAP backbone engineering, and its peer-to-peer statistics is also attractive for customers. Second, for surprising a stable network, optical switch will be installed for all gigabit users. Currently, these optical switch are installed only for 10G users. Installing them can install them to all gigabit Ether can increase JPNAP services availability. Third, to meet our ISP's potential demand, we need to prepare much higher bandwidth interface. For instance, multiple 10G ports or 40G ports, 40G. So we need to evaluate those technologies and interoperability between equipment. Last, this slide showed our wish list. As I mentioned, we installed a new switch platform last year. However, we already ran out of almost all slots on the switches. So we strongly request a much bigger switch platform to our vendor. It has high port density, and it had also have wider backplane. And currently, considering current traffic growth and some ISP demand, I guess we cannot wait the 100 gig interface standardization. So we need to seek the next generation architecture for XP. And that's it.
Chris, switching data.
I'd like to thank Chris for giving me the chance to come up here and speak. And even though it was a short notice, my marketing department still managed to make these slides for me. Switching data basically has continued to grow. It's still primarily space-oriented, and we still have the 10 IXs that were formerly known as the PACs. Switching Data has branded those as a product, so PACs is now a product name. Our cities still include Atlanta, Dallas, LA, New York, in Northern Virginia, Palo Alto, Philadelphia, San Jose, San Francisco, and Seattle. We use Extreme Switch, which has worked very well for us. And this year, we're basically going to be putting the 10 gig switch in Palo Alto and New York. You'll probably see a press release on that. One of the things I do want to say is that this is the second time I've made this speech, but this is not the second time PAX, where Switching Data, has made this speech. And usually it's always predicated by the speaker telling everyone that it is the, this year's the anniversary of the first connection in Palo Alto. Well, it's the 14th anniversary for Palo Alto now. So hopefully the next time we say this speech, it will be the 15th. Other than that, our new initiatives are going to be just expanding our exchanges in the metro areas. We've been very successful with that in Palo Alto, extending it out as far as San Francisco and San Jose. In New York, with the recent acquisitions that Switching Data has made, we'll be interconnecting buildings, hopefully in the New York metro area, as early as fourth quarter this year. And questions, and that's who I am. Thank you very much.
Thanks, Chris. I have Heck Steinman from AM6 next.
Okay, main developments in Amsterdam on the exchange last year. We migrated from a ring infrastructure to a hub-spoke topology, and the purpose of that was to make the inter-switch link capacity more manageable. And one of the ways we're going to do that is to connect high bandwidth customers, which are essentially 10 gig E customers, directly on these core switches. Conceptually, the network looks like the drawing on the right. We've at the top two core switches, and at the bottom, left and right, two Ethernet edge switches connecting customers up to 1 gigabit Ethernet. In the middle, there's a photonic switch, or some people call it a fiber switch, where we connect 10 gig E customers and who then get switched to the active core switch. So the broken lines in this picture are the backup connections, not carrying traffic, and the solid lines are the traffic carrying connections. Whenever one of the solid lines break, the whole thing swaps over to the other side. Well, to make this possible, we introduced new switches in the core, Foundry MGH switches with 32 10 gig E connections. And we introduced photonic switches from Glimmer class for the 10 gig E connections. And we also use these switches to migrate, we also use these switches to migrate from the ring to this infrastructure to the hub-spoke topology. That was outlined in a presentation by a colleague of mine, Romeo Zwart, in a previous NANOG meeting. On the services side, we introduced aggregated gigabit Ethernet connections. On the foundries, that's a limited 802.380 implementation with not the dynamic parts of LACP in that, which essentially means you cannot dynamically add ports or take ports away. And load distribution is done on source destination IP, which works pretty well. We've shown some issues there, mainly with one specific router with which sourced packets with a source MAC of beef food beef, and in another occasion the router kept swapping traffic from the one link on the trunk to the other. These issues are solved now, and this service really goes well. 10 gig E customer connections, we started offering that in December. In the 2 months now we have delivered 10, and it really works great. The uptake of 10 gig ports on M6 is much faster than we expected. And one of the important things we need to do this year is to scale the network to cope with the expected 10 gig interface density. Other developments for this year, we will introduce route service. It's on request by many of our customers. And we will give, what we will also do is we will give an idea of the performance of the exchange by delivering live data of measurements by boxes from the RIPE NCC test traffic measurement project. That will give you a live insight on the performance of the exchange in packet loss, packet delay, and delay variation. And then one of the really big issues I'd like to solve, which was also mentioned by previous speakers, is that I would like to have my edge switches on a much higher availability and have hitless software upgrades, etc. As an example, we have one switch which has about 80 routers connected, and each have up to 100 BGP sessions on them. So rebooting that router really gives a lot of BGP flaps, and we've seen stabilization of this all taking up to half an hour or so. That's one of the things we really think is important. That's it. Thank you.
Thank you. Akio from Telehouse.
My name is Akio Sugeno from Telehouse. First of all, I'd like to thank Chris for volunteering moderator. Thank you very much. Without him, this couldn't happen. Thank you very much. Appreciate it. I'd like to give you an update of the Telehouse exchange point. In New York, activities in last year is we upgraded the switching fabric at post 25 Broadway in the 60 Hudson. Also, we upgraded the trunk capacity between these two nodes from multiple gigabit links to two 10G gigabits. Now both nodes support 10G import service. Activities planned for this year is we are going to extend our nodes to 111As, and this should be available in February this month. And this 10G port via speed port service is available on this node. And we are having this kind of star topology, and we're going to have the 10G link, direct 10G link over dark fiber. And we can service any suite in this building. And also we're going to need the upgrade on our monitoring system because we have now 3 nodes. And also we are getting quite a lot of the requirement or of the current existing customers and also potential customers about the VoIP peering. So we are going to start some kind of trial this year. In Los Angeles, last year we cleaned up the V6 issue. You know, we were still using the 3 FFE space, but now we're using 201 space. Also, we upgraded the switch fabric, and also there is a lot of demand from the One Wheelchair, so we install a lot of dark fiber into the One Wheelchair building, so give them easy access to the building. Activities this year is, of course, we need to upgrade the monitoring system. Also, we are kind of interconnected LAAP and Scenic, the Pacific Wave, and they're kind of merging into one organization. So we need to develop and discuss the policy issue, technical issue, many issues with them. Also, based on the report from our let's say sales team, we are kind of running out of ports, so we may need to replace this box for a larger box this year. And the issues also, and this year will be just like any exchange point operators, we need to provide a faster port at a lower cost, of course. Also, we need to provide a proper hardware because in the past we are talking about jam frame peering. However, now we are getting the VoIP kind of thing. So we need to have a nice hardware to support show pocket like voices. And that's it. Thank you very much.
Thank you. Last but not least, Lane from Equinix.
Hi, I do R&D for Equinix, and I know Jay really wanted to be here to give this talk. He loves to get up in front of you all. But one of the developments in early '05 was one of our IBXs finally became sentient, and we had to send Jay in to figure it out. And yeah, those are little floating RJ45 connectors there. So this is pretty brief. I took a little bit of a different tack on not doing a rehash of the typical exchange point update stuff, but some of it is covered here. In '04, we basically had pretty good fabric stability with continued doubling of our traffic over the year. Did a lot of link aggregation, statically configured, and moving forward would like to see LACP and some of the issues that solves for link aggregation in '05. And one of the things we were able to prove to ourselves in '04 and I think to the participants was that we could turn on S-flow sampling on all of the ports of our switch fabric, and nothing broke. Everything worked fine, and we were able to get some pretty cool traffic graphs per kind of source and destination MAC address matrix for exchange stats. There's nothing that really didn't work in '04 from a truly broken standpoint. I think there was a lot of things we kind of felt were lukewarm that we'd like to see improve going forward. One is I think we pretty much got sick of the existing generation of switches that we're on, and really looking quite forward to getting the next generation switches out, not just for more 10 gig and port density, but really because there's a lot of features that are going to be really helpful to exchanges moving forward. Things like hitless failover, hitless upgrades, and just a lot of nice features, a lot more control over rapid reconvergence of metro and layer 2 topologies, a lot better support for things like MAC filtering and BPDU filtering and things that keep an exchange up all year round. Secondly, I think IPv6 was kind of there, and we got a lot of interest, and I appreciate all of those folks connecting to our IPv6 exchange. I think it was another year of sort of just incremental growth there, but there was nothing really exciting like huge traffic growth or any new demand caused by applications or content experiments. So moving forward in '05, I'd love to see if anybody has anything innovative to actually drive real IPv6 traffic or content. Would love to work with people on that. And I think the last is in '04, in the US, dark fiber isn't quite as plentiful, and I'm a little bit jealous of my friends over here in Amsterdam. They have life pretty good. And we just don't have a lot of plentiful dark fiber in all the markets that we're in, and as we fill up data centers and move to additional data centers, that was pretty restrained for us in '04, our ability to link those sites at high capacities. So that kind of became a big commitment for us in '05. It's something internally we've been, fighting for and making real strategic for us. So, what's interesting is I look back now at 4 of our metros here, and we've got kind of a different solution in each market, just depending on the situation in each location. So in the Bay Area this year, with the addition of our 3rd data center, we have some dark fiber, not enough to just throw dark fiber at the problem, but enough that if we put DWDM on top of it, we can do some interesting things. And so we're doing that now. We're also adding some sonnet muxes hanging off of that DWDM layer so that we can go all the way down to T1 and do any kind of sort of layer 1 TDM cross connect you need. In LA, we have inexpensive dark fiber in sort of, I'd say, dozens of pairs available to us, and so we don't necessarily have to light up a DWDM layer and spend the money on that equipment to solve the problems that we have in LA. In Ashburn, our expansion was really handled as more of a same campus situation, even though it's kind of a big campus. It's 1.5 kilometers away from our existing sites in Ashburn, but we were able to actually get permits to construct conduits all the way out in diverse paths to that site. So we literally have several hundred pairs of multi-mode and single-mode pulled between those sites. So anything you can do with fiber, you can just view that as an expansion of the building in Ashburn. And then in New York City, I think moving forward, we'd love to see sort of the same approach taken as what we're doing in the Bay Area today in 05. But I think we're sort of getting by right now on some leased capacity over Sonnet to link together our switch fabrics. And then as we see kind of customer demand grow, we're looking at options for dark fiber and DWDM there. So I think you'll see a lot of that continue to evolve for us moving forward this year. We do have, finally, I'm happy to report, we have some aggregate exchange utilization graphs available on our login site. For those of you that have been waiting a long time for that, thank you for your patience. And we have a pretty good infrastructure in our stat system now, so we can do some pretty neat things moving forward with that. And if anybody has more ideas, I'm definitely happy to talk to you guys about that. 10 gig, we are also working on it. We've been working on it for a while. We've had vendors in our lab since, I think, February 2003 for 10 gig switches. We've kind of taken the approach of waiting for all of the features on our wish list to be provided to us and to be able to be tested. Things like lots of brutal combinations of features in parallel and seeing that those scale and don't cause problems for the fabric. So we're just about ready to turn the corner on that, I think. And as soon as we get this DWDM project rolled out in the next month or so here in the Bay Area, we'll be jumping on to upgrading Ashburn to our next generation switch platform. One trend that we're seeing in the Asia Pacific region, I think this year, I won't go into a lot of detail, but I think it's pretty interesting for this audience here, is we're actually seeing some interest in a commercial kind of PTT neutral exchanges in various markets in Asia, driven primarily by content providers and US Tier 1s expanding into the global peering game in Asia Pacific. And it's something we weren't necessarily really expecting, but I think we're seeing it happen, and that trend will become a little bit more evident over the course of the rest of the year. And I think another thing that's kind of interesting, it's not really peering news for the NANOG community, but I think it actually has the potential to impact some of the decisions you guys are making in terms of network architecture and what types of services and what types of routers, PE and whatnot that are in these neutral facilities. We're actually seeing, some fairly large corporations move to a model of, say, moving away from these large sole source contracts for all their connectivity nationwide and building out their own wave-based backbones, and so that those backbones are shielded from building moves, adds, changes, whatever, on their part. They're showing a pretty strong desire to terminate those into carrier-neutral facilities. I think both for the flexibility there as well as for some of the price points that they can get. And then they have a pretty broad fan-out of the second tier of their hierarchy. Most of these companies are reaching, a few thousand locations with that second and third tier of the hierarchy down from that backbone. But these are 10 gig wave type backbones that enterprises, I'd say a handful today, but more and more moving forward, I think this will become a trend. That's it for me. Let me know if you have any questions.
Thank you, Lane. I just wanted to close with just a quick comment and question. How many of you thought that this panel was valuable to you? Okay. There were 4 other IXs that we just didn't have time to get on this panel that I had to turn away. And I firmly believe as a network operator that this panel is very valuable, especially if we keep moving down the trend of finding out what's working and what's not for IXs. Particularly when you look at the trend in Japan where they have such an incredible amount of traffic on their exchange, they have different problems than smaller IXs in the US might have, but we could definitely learn from them. So I hope that as we continue to go forward with NANOG that the IX panel is a more frequent part of it. But with that, I'm going to open it up to questions if anybody has any, and we do.
Hi, I'm interested in 10 gigabit Ethernet, and I'm wondering at what point does it make sense financially for an ISP to stop trunking giggies together and instead go to a 10 giggy port? Is it 7 giggies and you might as well just buy a 10 gig port for peering? Or is it 6 or is it 11? What are the economics with 10 gig peering?
I'd say once you reach that point where you've filled up 2 gig ports in a link ag and you need that third one, from the standpoint of the exchange, that's probably the right time to go to 10 gig. But I think that's more of a question for the providers because there's some pretty high prices out there for router ports for 10 gig. OC192 ports are still way cheaper.
So I've got a question, I guess, on the operation side of everyone's exchange. So my question is regarding whether each individual exchange has any policy for what type of equipment connects to the exchange, whether it's only routers, switches, you don't care as long as they connect, and if you do have a policy, do you do anything to enforce it, and what is that, and how do you see the increasing prevalence of switch routers kind of making that decision more difficult?
We'll just start with Chris and move right down the line.
Yes, PAX's policy has always been that a router connects to our switch. And very rarely do we make exceptions for that.
Policy at M6 is that we don't care what you connect to the switch, but we only want to see one MAC address, which is if you want to use your router, your switch port can only be your router at the end.
Generally, JPNAP not allowed connected to switch.
Yeah, at Equinix, it's generally we have a policy of 1 MAC per port. It could be, a switch router type hybrid device like a 7600 or whatnot. We're using something called like MAC port security to actually to enforce that on the port. So we actually ask customers to provide us the MAC address and we lock that port down to that MAC. And moving forward, that feature in the next gen switches is getting a little bit better and more flexible for us to use, and additional things like BPDU filtering and stuff we can layer on top of that as well.
NAP of the Americas, where it's getting a little complicated because we're allowing external peering via MPLS now, which I know is just wonderfully controversial, but we don't really care. Come on in, doesn't really matter. I do want to answer the 10 gig thing real quick also, by the way. We're seeing very little uptake. Everybody just privates. They just start doing tons and tons of privates and use the grooming platform on that. Single externally viewable MAC address. We do have a few people just doing BGP off of servers. But generally it's router.
So I guess I've got a question.
Can we let the last exchange answer?
Telehouse, we got both switch connection and router connection, but like other operators, 1 MAC address per port, and we do have the port security, just like he mentioned.
You got a follow-up to that?
So I guess my additional question is regarding the L3 switch routers and how that's kind of a difficult thing to differentiate, whether that's truly a router or whether it's a switch, and how the exchange kind of handles that issue. And
I think they were dealing with it by hard-coding the MACs in.
Yeah, as long as you can restrict it to 1 MAC per port and block BPDUs, for instance, from that Mac if it's incorrectly configured for some switch mode stuff. We don't care.
And one comment for Bill real quick is on the research and education side, one of the things that we find that's driving the 10 gig ports on the exchange is the high flow traffic, the 1.5 gig flow, 750 meg flow type traffic that we can't really entrust a load sharing algorithm for bundling giggies to handle.
This question's for Hank. Hank, when you were putting in the 10 giggies, did you notice any of the existing peers moving out of private peering and back towards more public?
We don't have a view on private peering because we only operate the switch platform, and all private peering is handled by the co-location sites, which are more or less independent organizations. So we don't have a view on private peerings. Yeah.
So did you hear about it?
No.
No.
Mike Hughes, Links. This is in sort of response to Ren's question because I do know of at least, I think, one provider that if they can get 10 gig ports or if they can get enough link aggregated ports on an exchange, they will move some of their smaller peers back to public peering from private, which means that they actually free up the private peering ports for their bigger peers then. So it's just causing them to reevaluate at which point they move to private or how they balance between private and public. I don't see anybody completely running away from private yet. It's just making people change what they're doing. The other observation, certainly about the 10 gig ports is, yeah, this real high price of 10 gig router ports on the member side is really kind of putting people off from our point of view of when we were working out how much it cost us to provide 10 gig ports to members. It's, from our point of view, what it costs, it's slightly less than providing 4 1 gig ports as a lag group.
Thanks, Mike.
Quick question for JPNAP. I might have just missed it if you went by quickly, but what kind of switch hardware are you using to handle your 60 gigs of exchange point traffic?
JPNAP consists of multi-vendor and mainly current main switch is Foundry MG8.
Thank you.